Yeah, this is a 26 meters width and 78 meters length. The gentleman asked me to have a clean room without any columns inside. So how to achieve it? So what we have done a cantilever at 6 meters level from the ground level. And then the next slide, you can see. So this is the arrangement. So there are all AC equipments have been placed on the cantilevers. That is 6.5 meters cantilever from on either side. And you can see a pipe rack is also there. And the structure which is built here, that's a D shape. This is meant for the walkable false ceiling, which is a 26 meters. It has been supported all through. So this is the finally all the equipments which are held from the rooftop, from the D-shaped structure, we could able to accommodate. This is the biological limited. They are making vaccines now, COVID vaccines. So this is a robotic technology. They are using it with a minimal manual intervention. So this is the kind of a arrangement they have made. In entire area, it was vacant for them to design what they want, because they were not very sure what the equipment is coming, where the equipment is coming, how to handle it. They were clueless in the beginning stage. That is the reason they wanted. So this kind of a 26 meters by 78 meters. So that is possible only. I just wanted to, can I get the marker please? There are on either side a 12 meters width block was available. From here, what I did, there's a cantilever I have made like this. If you look at the cross section, this is a cantilever I could achieve because this is a 12 meter span on this side and 12 meter span on this side. I could able to give it 6.5 meters cantilever. This is the height is 6 meters. And there is a PEB structure, what we have done here. And all the equipments have been placed here. And there is a 2.4 meters level. They wanted an entire space, which we could able to make with a suspender from this area. And this area is 26 meters by 78 meters is available for them. That was the, challenging, where initially we thought how it is possible. But all the people, they were happy ultimately. And even the equipment suppliers from Italy and Germany, they were also surprised how we got that much area, a free space without columns. So this is the finally, it is in the shape, we got it. Now it is a manufacturing stage now. To make a commercial complex at a faster pace, of course, this I have given in the earlier sessions also. So in a control-less data center in Mumbai, what we have done, they wanted a steel structure which has to be built in a no time. That means what the stage on 23rd June 2018, that was the stage. And if you look at the next, this is the 31st October 2018 data center, all 12 floors they have completed. That remarkable achievement has been made by Kirby with the help of course, so many engineers, and Hilti also, they made basically it is all the deck sheet has been dropped from the bottom. So they have fixed from the bottom. Hilti did that job for them. This is a composite flat slab structure. So which is a, I think I have given a much more elaborations in the previous sessions also. So I just wanted to go further. To create a clean room facility in RCC of room size 15 meters by 48 meters with a soffit at 3 meters, including lighting cutouts and HVAC ducts. This was the challenge was given by Bharat Biotech. So how to make it now? This is the ground floor where you are seeing all the clean room. That is a 15 meters by 48 meters. They wanted all the, if you can see, next slide, I'll come back to the, this slide. Yeah. So this slide, if you can see, people will think that what is this? The foundations are laid on the slab top. I'll explain you how. This is the basic cross section. So what their requirement was 15 meters by 48 meters, 2 vaccines they wanted to produce. In that, I have used these columns are suspended columns from the beam above. So this is the ground floor where they have started vaccines, I mean manufacturing of vaccines here. So these are the suspender columns, though that was designed as a concrete suspender, I mean tension members. If it has to be done in a present day, I would have used only steel structures because the steel is more good at tension. So this was the plan was given to us, 15 meters by 48 meters at 2 rooms of this size. You can say 2 rooms of a 2, I mean there should not be any cross contamination. So what ultimately we did, we have provided 2 staircases, 2 entries for all of that. They wanted one more thing. If you see this cross section, for some of the equipments, they wanted a higher elevation also. There also what we did, we have taken a suspender from here, all the suspended here, suspenders, 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 and this a inverted flat slab kind of a thing. At the flat slab is 200 mm thick. This is almost the panel size is around 5 meters by 5 meters. So that 5 meters by 5 meters we could able to design with a 200 mm thick with a required cutouts like this. All the lighting cutouts and HVAC cutouts, and later they have installed all the AC equipments over this. Okay. To make a cantilever slab of 10 meters by 10 meters for a library at TCS Deccan Park. TCS Deccan Park is designed by Mario Botto, the Switzerland architect. So that was designed by me in 99. I was working with CMAC Private Limited at that time. So basically this structure, I just wanted to give you how the architect should have a inclination towards the structural system, how he visualized, and we could able to make it possibility. So we have to appreciate that architect's view also. I just wanted to explain on this. This is a 100 meters dia. The columns which you are able to see that those 2 columns are here, and this is a 26 meter span with a course here. This 26 meters on this we have taken, that is 2 meters by 2 meters beam size. There are 3 floors are there inside, and that 3 floors to support that 3 floors with a 26 meter span, We have taken 2 meters by 2 meters. Literally, I was walking in the beam to check that beam also. From there, we have generated in the front shear wall. That shear wall we have taken up to the top, and after that, to make a T in shape, Tata T, that is 10 meters cantilever he wanted. And this is a 4.5 meters is the height. Library he wanted 4.5 meters. So what we did, we have taken a slab here and we have taken a slab here and a shear wall. With that shear wall, we could able to manage the deflection point of view. So otherwise 10 meters by 10 meters was not possible with the only beam at the bottom and supporting that. So that shear wall is supporting the top slab as well as the bottom slab. That is a deep beam, I can say. It's not only shear wall, it is a deep beam. It is acting like a deep beam. And if you look at from the other side, it is a library with a circular holes in that, because he wanted a feel of a ship, people sitting inside and reading the books. He wanted a ship feeling. So that is the reason he has designed like that. I mean, you can see how much a structural knowledge should be there for them to visualize this kind of a thing. Otherwise, for a normal architect and all, it will be very difficult to visualize this kind of a structure before designing the, discussing with the architect, structural engineer. To make rust-proof pipe rack in coastal area. So, of course, this is a very easy. Normally, pipe racks in a pharma industry, what we do, it's a steel structure. That was the norm. But where in Visakhapatnam, what we did, we have done with a precast members. So this has been subjected to hood in Visakhapatnam also. So 240 kmph wind speed was also there, but it withstood the requirement. And so many pipe racks were damaged during the hood, and so many chimneys were also damaged during hood. It stood with requirements, wind requirements. So if you can closely observe that the columns are also, we have taken up to certain height, a thicker column, and we have made a thinner column, and this is the way we have done. This is the in situ portion, and this is the frames what we have made at the bottom, and these are the inside members. So those are all precast members we have installed over there. To have a lavish driveway at cellar floors for high-rise buildings. So this is, of course, so many consultants are doing. It's not a new thing for you people, for a seasoned structural engineers. So this is a LEPL at Vijayawada, Lingamaneni Estates Private Limited. This was the visualization from the architect. This is the finished building. So what we did, we have taken 8.5 by 8.5 or 8.5 by 11 meter spans at the cellar levels. We have done a transverse slab at this level. That is also flat slab. If you look at, these are the capitals what we have done. This is a 1 meter depth. Capitals we have taken, and these are all the floating columns. These floating columns are supporting 27 floors. You can see that floating columns supported on the. So this is the driveway, what they got it. So for 8.5, we have done 1 meter by 1 meter. So that is the column was 1 meter by 1 meter. Why 8.5? People must be surprised. for a car to accommodate 2.5 meters by 5 meters is the minimum requirement. If you provide 8.5 meters by 8.5 meters grid, so we can accommodate 3 cars. If it is 11 meters by 11 meters, we could able to accommodate 4 cars and with a lavish driveway. So after this, at second level, second basement, we have transferred all the loads. Why? I mean, they wanted all the columns to be taken in the initial stage, but they could be able to avoid it, that one more level excavation by getting the required parking spaces. To achieve clean interior space in an existing load bearing structure. It's a very simple but looks very innovative. So assume that this is the entire area for a residence. Mr. Vinay Gupta in Mushirabad, Hyderabad. He had all the walls. That was a load bearing structure. He wanted a clean space like this. So how we could able to achieve? And he doesn't want any beams coming below. Otherwise, what happens? His height for the interior space will reduce. That was only 3 meters height. So he wanted a clear height of 3 meters so that he can do his interiors in a better way. So what we did, we have placed all the plates like this. On the rooftop also we have placed the plates like this. And we have done a beams on the terrace level. And we have stitched that. I mean, we have welded that so that all the slab will be stitched. Then we removed all the walls below. Of course, we had to do some lot of exercise because all the load has to be carried only by end walls, which are very good. And don't experiment on the coastal area because it is in Hyderabad and good soils are available. Then we could able to do that. But in coastal area, there is a possibility of a settlement because that's a very difficult, but very carefully we'll have to analyze and then only we can achieve this. So this was the, I mean, interior space. They could able to get it with a beautiful home theater and a big bedroom. Everything they could able to achieve with that. So after that, they wanted to do a false roofing over there. So they have done encasement also on the rooftop to achieve a good mezzanine height in a double height floor for a commercial complex. So what we have designed is a commercial complex in road number 12 Banjara Hills with a assuming that it's a for a used for the car showroom. We have kept 16 feet 9 inches as the beam bottom, and that was a nice structure we did. But ultimately what they did, they have given for a leasing for a bike showroom. For a bike showroom, they don't want a good height. They wanted a shallow 2 levels parking. So what we have done, that was the, from here to here it is 18 meters span. 18 meters span, we cannot, if I give a 18 meters span, lattice and all, we are losing much of the height. So here also this is 12 meters. What we did ultimately, so this is the cross section. So if you look at this carefully, I'll go back once again. What we did, we have done a lattice here. This lattice, we are able to break this beam into 2 parts. That is 12 meters and 6 meters. This is anyway, it is 12 meters. What we have done, this is the beam, what we have achieved. There are UV sections we have taken 257, 3 numbers with the top and bottom plates with a deck sheet above. And these secondary beams, what we have used is a UB 203. We could able to achieve this height within this without losing much of the space. So here the deck sheet, and we have used the shear connectors also this place, so that I wanted to make it as a composite section. And this section we have supported on this lattice. if you carefully look at this, we could able to give a opening of 2 meters width also. Why 2 meters? They wanted a showroom above, which they want to take the bikes above, and they wanted to keep everything here. There is a lift here provision. They are going to take it and take onto these premises. They want to display in 2 levels instead of 1 level car parking. I mean car showroom. They wanted in 2 levels. So ultimately, we could able to achieve this with this lattice. If you carefully look at this, where the requirement is there on the ends and the middle, we could able to give a lattice which is supported on the rooftop and the mezzanine level, and our main beam is touching here actually, and which is made into 2 parts. So this opening is for the bikes to come. I mean, for the 2 segments, they want to go with this opening. So thank you.